Welcome back to Behind the Scenes at Technoset. Part 5 is going to focus on our fixed head capabilities. Here at Technoset, we've got 8 Miyano fixed head machines that specialise in one-hit finished part machining. So straight away we're going to take a look at our BNE 51. Now this BNE 51 is a slightly older version of the Miyano BNE, but a really solid machine, great, very quick, really versatile production machine. We're just going to speak to Sam. Sam, so what have we got running here today on the BNE?
So we've got the probe housing, so it's an order of 300 parts. It's been running well lately. It's got a few critical features, visually mainly the thread.
Yeah.
So we have to check the tooling on that, make sure there's no chatter on the thread. We've got the undercut that we have to keep checking on the Vici. But other than that, it's a pretty easy running part.
Good stuff. So cycle time on this one, Sam?
So cycle time is 390 seconds.
Yeah. And do we get continuous running, any unmanned out of this?
So we have had about 30 plus unmanned before, so we're trying to stick to that, see what we can do to make it better, get more out of it in the future. Yeah,
so as we finish on the second shift, making sure that we've got a few hours of unmanned production is obviously critical to efficiency in the production and also helping the economics of the job, really. When you're inspecting this part, you talked about the visual aspect. What kind of things are you looking for when you're visually inspecting the part?
So mainly checking the threads, as we've had issues with them before. So the internal thread was the main problem we had at the start when setting the job, but we've slowed down the freezing speeds to make sure it's as least chatter as possible. But other than that, that's it.
And being an aerospace part, it's obviously critical in the visual acceptance, surface finish, and then you're capturing all of your measurements through MeasureLink?
Yes, it's all on MeasureLink.
So that enables you to see all the stability of critical dimensions and so on?
Yeah. So we check the part every hour and it all updates on the system.
Good. And in particular, Sam, the BNE, you like the machine, nice to set, to run, really robust?
Yeah, it holds size really well. Probably the better machine in the factory, for me anyway, personally.
Yeah?
I love it.
Got your little favourite?
Yeah, that's it.
Good stuff. Cheers, Sam. Thanks for your time. We're going to have a little walk now down. We've got an ABX 51 that's just finished the production cycle, about to go into setting on a billet job. So not only do we have the capability to bar feed on these machines, but we can also billet and chuck as well. And that's both main and second spindle. ABX 64, which is on a specific project we can't talk about. And then we've got Jay running one of our 2 ABX 64s, SYY2. So this has got 64mm bar feed capacity. And Jay is running here on an aerospace part that we do regularly. Jay, so just talk us through the part. What's the material, first of all?
It's a titanium material.
Good, and how many? What's the order quantity for this?
For 200, and then we've got another order for 200, so 400 in total.
Yeah. Brilliant. And so, in particular, when you're setting and running this, what are the key issues that you face, complexities in production?
So the flange size is critical, and the thread is critical because you've got to keep control of the minor diameter, plus trying to keep it in size. Other than that, it's a pretty good runner.
Yeah, it's been a stable product for us for a few years, hasn't it? So it's always kind of nice when those stable products come back and they get into production quite quickly. You know them, particularly you've ran this product for quite a while, haven't you?
Yeah.
So you use MeasureLink on this, Jay, capture all your key features?
Yeah, use MeasureLink, capture all the data, and then we can keep track of tool life and stuff like that. So now I've got tool counts in the machine. So we know how long inserts are going to last, or roughly going to last, and so we can change them early and keep production and keep this going and more. keep it efficient.
So as well, does that give you confidence when you're leaving the machine unmanned or you're walking away to carry on with another set? You know that if everything's right, you've got consistency until you come back to the machine.
Yeah, definitely. I don't really have too many issues. I used to have issues when we first had this job. We didn't know what the tool life was, and tools end up breaking. Then obviously, we started.
Over time, you get the data that you get from MeasureLink. So in terms of unmanned production, what did you get out of that, Jay?
I keep it safe. About 10 parts I usually do, because the rough and tips last 30 parts until we got to change them. So I just try and keep it safe. It's a good 10 parts.
Well, when we walk back in the morning, we don't want a machine
broken down.
Or tools welded to material. Yeah. And it generally in cycle time for this part, Jay, what's the total cycle time?
Right now, we're on 15 minutes right now.
15 minutes?
Yeah. But I think it's about 16 and a half minutes.
Okay, good. And there's a fair amount of material to come out of there, so that's excellent. Well, thanks, Jay.
Yeah, no worries, thank you.
Cheers. So we have our 51mm machines at the far end, and we have our 64s, and then we have a bank of BNJ 42 SYs. We've got two older versions of the machine. Pete setting up a job. It's going to be a brass job. Runs all the way through the night. That one we actually run it into some deionized water to prevent any staining or anything like that. It gives the parts a rinse as it's going through the night. And then we have our two newer version BNJ machines, both running again aerospace parts. So common theme down this fixed head line at the moment is it's all aerospace product that's going through, which means that our MeasureLink capabilities and the machine performance capabilities are really important. Dinis has ran off, so he's seen us coming and he's legged it. But just to give you a brief on here, we've got some bush. Oh, here he is. I thought he'd done a runner. We've got an aerospace bush. Come on, Dinis, come and talk to me a little bit. So just talk us through the two BNJs that we refer to as 3 and 4. On BNJ 3, what have we got running at the moment, mate?
We got running with that aerospace.
It's a bush.
It's a bush, yeah.
Bush. And what's the order quantity for?
The order quantities are 400.
But this is a
continuations order. We get like a 4 or 5 continuation, same repeat job.
So when you're running this, and this has been running for a little while again, what are the key features on the part that you're looking out for?
Key features on the part, we look over the length here, what's 2.5 to 2.55.
Okay.
And we get that threading as well. It's quite tricky, that thread, because of the material situation.
So the material, it being an aircraft stainless steel, is we have to go through a gauge check process every morning, don't we?
Every morning, every daily, that threading gauge check every morning.
And how do we check the thread gauge every morning?
And with the inspection, we have on a sheet there. Yeah. The inspection people are coming. They come in, they take the gauge to inspection, they check it, and then they have some program as well on the VG where they check it, and they stamp it. Yeah. Every morning, Tyler did it. Yeah.
So this is the card for the evening shift, but we've got. So every morning it goes on the VG, the screw plug gauge gets checked for wear, and then we have a master in final inspection for checking that as well, purely because of the number of parts that we're doing and the wear on the gauge.
Yeah.
So generally it runs well. What's the cycle time on it, mate?
Cycle times we get here on 282 seconds per part, and it's running well. Longer we follow the procedures on our layout, we change the regular one is required to change.
So we've been running this part for a long time, so we know tool life. We have it on MeasureLink.
On MeasureLink, and been running fine.
Really good.
Very good. Yeah.
Brilliant. So, what about on BNJ4? It's running a very similar type of product,
but similar, but it's quite tricky because that one you have a different material. It's
so this is an Inconel.
Inconel material is quite tricky as well, and we've been running. We didn't run in this job long time ago. We just come back recently, and in the past time we quite challenge job to run because its material is quite hard. And then that's why we can see we put like 2 roughing, one finishing, and one the radius down as well.
Okay.
To make sure it's running fine. Apart from that, we get that on the board is quite. We don't have a major issue on the board, but the tricky part is the.
Is a roughing, a fair bit of material to come out.
Exactly.
Tough material to machine. So again, just looking at the part, visually really important, being an aerospace part and critical on the features, so using MeasureLink again.
As well,
So all of our data is collected and stored for us to analyse and understand how productivity is going. Thanks for your time, Dinis. That's really good. I'll leave you with that part. So just as a recap down the fixed head section, you can see that it's dominated by our aerospace components. It's not always like that, but certainly at the moment very prominent down the line. We're using MeasureLink all the time to collect our data. Gives us great knowledge about tool life, about productivity and consistency of part. Hope you've enjoyed that, and we'll catch up with you again soon to have another look at a section of Technoset.